Thank you all for joining us today. Are we going to get started? How are we feeling?
Good.
Have you been enjoying the conference so far? We know we're close to the end of the day, so we will try to keep this as exciting and interesting and interactive as possible. Hello, we're really excited to be here with you today. We will be talking about, surprise, GenAI. Who isn't, right? We will talk about our journey of building a FinOps solution, an AI solution for a FinOps solution. So we have an AI feature that is embedded on our FinOps solution. This is the journey of it. We CloudHealth now rolls out Broadcom. So we will talk to you a little bit about the proliferation of Broadcom's AI use cases, what it meant for us to build an AI solution for FinOps, how we did FinOps for AI, which is cost management of models, how we built it, and how we optimized our LLMs. Introductions. I have here with me Darien. He is a generative AI architect, but fun fact about him, he is a Flair bartender. Who here knows what that is? Okay, I did not know what that is when I saw it. Okay, so for people who didn't know what that is, he can basically jug in bottles and like put on a show while bartending. Isn't that so cool? My mind was blown.
Yep. And I'm here with Sanjna. And fun fact about Sanjna that I still have to see some video evidence, maybe, or she does Argentine tango dancing, which is very impressive as far as I'm concerned. So take it away.
Okay, so we've covered interesting things about us outside of our day job. Let's jump into AI use cases that Broadcom, our company, has. Outside of natural language interfaces, which are embedded chatbots, you will interact in natural language, and we will basically it is almost an agentic interface which can create reports for you. We also have the private AI foundation, which is built on VMware Cloud Foundation. We've integrated with NVIDIA for VMware's virtualization. We have Spring AI. How many of you here have heard of Spring? Okay. So Java is one of the most popular languages that developers use. Spring lets you code and build AI solutions in a language that you're comfortable with. We have Jericho AI, which is an Ethernet switch for AI-driven workloads, and XPUs. Broadcom is really known for this. It's a specialized chip company, and that's what we do for hyperscaler data centers. Outside of all of these wonderful things, internally we are a multi-cloud, hybrid cloud company. We use a diverse range of LLMs. Every single LLM you can probably name, we use it internally. Okay, so our AI solution that we're here to talk about is Intelligent Assist. Why did we build Intelligent Assist? To answer that, we have a short video. Meet Intelligent Assist. You can type any question you want. It's in English. And in a few seconds, you have a report that's created. You can open a report and save it all in 1 to 2 seconds. So, being a data scientist, I was a FinOps practitioner for 4 years prior to my now role at CloudHealth as a product manager. And something that I really struggled with is creating this almost the same themed reports again and again for different customers. And it got faster over time, but it took me some time to get there because you first have to understand the data set. You have to understand what each of the columns mean. Something like AWS Curd has hundreds of columns and new columns are added every day. Now the whole Focus initiative, we have Focus Export. So this is just definitely an evolving space. You need to be a domain expert to really know what the data sets mean. But FinOps practitioners are not engineers, right? You want to get the cost in the hands of engineers. So this interface helps solve that high barrier to enter and create your own reports and be aware of costs. I spoke about some of this, but what is the hardest part of building intelligent assistant? What makes us special? We navigate through complex large schemas. We deal with hundreds of columns, billions of lines, as everyone knows, and sometimes non-intuitive names. I think in this room, we look at names like unintended cost and we're kind of used to it, right? Because we talk this language, it doesn't really bother us anymore. But I spoke to Darien, who has absolutely no idea what the curve is or has not seen these columns every day. He's just like, he has no idea what any of these words mean. What is meter writing? What is an unintended cost? What is ancestry numbers? These are all column names from major cloud providers. So this requires, if you need to create a report on top of data sets like these, you require deep domain expertise to understand relationships between these fields. We try to solve for that. Ambiguity in natural language prompts. When you're garbage in, garbage out, right? If your response is just as good as you can make your prompt be. If a user asks a very vague question, like what was my easy to spend, you leave the LLM guessing. This is really hard to solve for because people do ask ambiguous questions. Customization and granularity. If you look at your hourly data versus monthly data, there is so many fields that are very different. Data is reported fundamentally differently. Schemas are different. And your primary keys can also be different. Constantly evolving data. Now we have focus. We have a completely different schema. We have a completely different way of calculating numbers. We have to keep up with things like that. Okay, let's talk about our journey just a little bit before I hand it off to Darien. We started building this. We are GA today, by the way. Everything you saw was not just a demo. We have it live. Step one started off in 2023. We started off with an initial evaluation of foundation models. We picked one, we're keeping confidential for now, and we started building with a budget in mind. Step two, we overshot the budget by 300%. Fortunately, it was private beta, and so the numbers weren't as traumatizing. Step three, we figured out what costs were. We expected it to behave a certain way. It did not. We had latency issues. Accuracy was not so great. So we decided to migrate.
Okay. Thank you, Sanjna. I'm going to try to dive a bit more into, I suppose, the technical side of things now that we have some of the motivation for why this is important. And as Sanjna said, I'm not as well versed in FinOps as every single person here. So,
I'm so sorry. I missed out on a major part of his introduction.
Yeah.
I am so sorry. I don't know how I missed this. So, who here knows the word Kaggle? When I say the word Kaggle, who here knows what that means? Kaggle and not Kaggles. So, he is a Kaggle Grandmaster. Just to give you context, so the Kaggle community is 23 million ML and AI practitioners. So, the huge community, and only 200 to 300 of them are Grandmasters. So, they're extremely rare to come by, and we're very fortunate to have hired him. He is extremely smart, and if anyone knows LLM, it is this guy.
Thank you.
I'm so sorry.
I forgot too. Sorry. Yeah, as Sanjna said, a lot of my expertise comes in building real things for various companies, applications, competitions. I love it. So when I talked to Sanjna a couple of years ago about FinOps, it was pretty exciting because there's tons of real problems, tons of difficulties that they face, tons of consistent things that they need improved on or automated, and lots of pain points. Also lots of complexity, as I quickly learned. So if we're going to build a solution, I think these are sort of the 6 fundamental tenets that we want to get across. So the first is that you really do want to work backwards from real value. If you're not talking to someone who's really suffering or, understands what's difficult, then you're not building something that people are actually going to use, unless you're lucky. So talking to Sanjna, understanding where real value can come from lets us build a solution people are going to use and enjoy, and that's worth something. It brings money or time to value or whatever we need. So moving forward with that, I think this is more of a general software engineering thing, but focusing on atomic building blocks is really important, especially so with generative AI. Because people get too ahead of themselves, you get end-to-end demos in like a day that people are putting out there. That's not how things work. You want things to be testable, repeatable, observable, and monitorable all across the board. So we look for those repeatable components so that when we build a solution for FinOps for this particular use case, and there's another use case that comes along, we're able to migrate some of those components, copy some of them, modify some of them, and we're moving very fast time after time. We also don't have to build from the ground up. Like, this is true of Kaggle or anything in software, but you should be looking at what other people do, what's new in the industry. And I know how overwhelming it is, but we should be building from that sort of state of the art. Now, don't chase every new hype that comes out, but understand what works, build from that, and then understand where you need to add custom functionality or code in. Towards the atomic bit, you do want to build a frame. Don't just build in a silo for yourself for the one particular application. We want to extend this. This is like, I don't think it's going anywhere. I think more and more things are going to become empowered by AI. So building an extensible framework as intelligent assist is important. And then obviously, I mentioned this before, but be pragmatic. Don't chase everything that comes up. Just because a new framework is mentioned in the news doesn't mean that your team needs to spend a month implementing it. Make sure you're doing due diligence, moving forward, being pragmatic. And then this ties into the first thing again. If we're triggered by value, if we start based on value, we should constantly connect with stakeholders, with the people that are using it, so that we can iterate and keep understanding where we're missing and where we can grow and where we can continue to drive value. So this is kind of what it looks like under the hood for us. This is supposed to be a bit messy for you, but just wanting to showcase that it's not just an LLM wrap we're talking about here. It's software engineering, it is pipelining, it is growing. Even this is months out of date and has changed since then. But each one of these is an individual workflow, and CloudHealth is probably our most successful candidate that is here, which on the next page, you can see this was the same long vertical workflow split over. So these are mostly just tools, which if you're familiar with LLM lingo means like a microservice or something like that. And some of them are LLMs, and some of them aren't. Some of them are just logic in code that runs right there, and some of it is a server, or some of it is a pre-existing tool. So we'll get into that next. I think Sanjna is going to take this one to sort of highlight a few things before I jump further.
Yeah, so we will talk about how to optimize AI costs in just a little bit. Before we do that, we want to give an example of a real feature that we have called Smart Summary. Basically, what this feature does is it gives you a single sentence summary of explaining every single dollar of your cost. So for every usage you have, every unique type of usage you have a single sentence summary, almost in a Goldilocks size, if you will. It's not just a product name, it's not a line item in your code, it has just the right size and the explainability in it. We have I don't know if you can see it, but in yellow, the yellow box around it is change reason. So we're able to explain why some cost has changed over a period of time. If it's usage increase, if the volume-based tiering changed, or if it's spot dynamic pricing, we can explain it for you. And we have a link here that says intelligent assist recommendation, which basically pre-creates a prompt, and we're able to generate generic non-resource based recommendations to optimize. So you can do all of this on one page. And based on this example, we will talk about how we looked at optimizing AI.
Yeah. So if the previous, thank you, Sanjna. If the previous things we talked about were how to build an AI towards general usability, and in this particular case, FinOps, then think of this as more how FinOps helps us not burn money on a day-to-day basis. And we've learned some of these things as we went, and some of them I think are just you do your diligence ahead of time. So as Sanjna showed, Well, actually, these are the 6 things we're going to jump through. We're going to go through each one individually. So I'll just jump in to the next one. So this isn't the best chart, but I think it gives a good picture of the model landscape that exists. This is probably still very out of date and all came from it, a few months ago. There's been so many new models coming out all the time. So even if you want to use an LLM or an embedding model for lookup or something like that, that doesn't mean you know what model you want to use. Even if you want to use Google or Microsoft or something, that doesn't guarantee you know what model you're going to use. There's different sized models. There's older models that maybe worked for you before. There's all sorts of considerations. So make sure that you understand the considerations when it comes to optimizing this. There's latency. That's going to be a key thing for your stakeholders. How fast this is coming back. There's obviously costs and how that's broken down versus prompts and completions. And then there's what the model is good at. Some models are better at coding and some are better at text generation. So be aware of these things and do your research and make good engineering decisions as you move forward. So prompt engineering is kind of not my favorite word, but there is some truth to being able to engineer prompts well. I think the users themselves have to be better and become prompt engineers, but we too can become better at this. So to that end, we follow a relatively clear formula. You want good instructions that tell the LLM what to do. You want to make sure you're clear on what the task that you're trying to accomplish is. And then within that, you want to make sure you have examples. Like, there's almost no case I can think of where examples aren't useful. They're going to a static part of the prefix, a part of the prompt. And we'll talk about caching in a minute, but that means that it doesn't cost you very much and tells the LLM a lot about what you expect from it and what the outputs are supposed to look like. So by including those examples, we get to tailor it to this exact format that we want. So you do have to make sure those are representative. You don't want to overfit to a particular type of query. So, be the human in the loop and make sure you pick the right things and you understand the task at hand. This also helps with minimizing length outputs. If you sort of let the LLM ramble, you might end up having to rip out the answer you actually care about out of a lot of text. So, as I mentioned, there's within your prompt, the thing you send into the model, there's going to be a static part that doesn't change. Assuming maybe you have a prompt that summarizes a response from GraphQL or something like that. There's this huge amount of text, instructions, examples, all sorts of things that doesn't change. And a lot of LLM providers, Google, OpenAI, Anthropic, all have implicit caching or explicit caching that you have to enable. What that means is that if you put the same prefix in and it detects that, then you can pay like 75% less for those tokens. So in our code base, 95% of all the tokens we pay for are static, meaning that if we cache them, we save 75% or more on 95% of our usage. So it's essential that we do it. The other thing to be aware of is if you, for some reason, put dynamic information at the beginning, you lose all ability to do that. In this image, we can see that just one letter wrong at the beginning of a prompt means that you're paying for the whole thing as if it was brand new. And then on top of that, we do application level caching. So every step of the way, we sometimes don't even go to the model. We say, have we seen this before? Have we cached this to Redis or something like that? And can we return it directly to the user? Is it something static or something that hasn't changed?
If I can jump in with an example here, just so that we understand. So when we talk about caching and being really specific and precise, when the question is, what is my cost versus follow-up questions, and what is my cost?
Yeah.
We lose our caching capability there. So it's just that sensitive. And with, when we talk about examples, we keep saying the word examples, we have to provide examples to the model. An example of that is someone might ask a generic question, like if you take this feature to a C-suite, but we demo it, the first thing we see is they will ask the model, what is my cost? Super generic, right? Like, what do you mean by cost? Are you talking about build cost, amortized cost, effective cost, what time period, what cloud? So you will essentially allow the LLM to make these assumptions for you. But if we step in and provide these examples of what a user might mean when we say cost, what is the meaning of a build cost, of amortized cost, of list price, That's what examples mean. They really help drive these conversations towards accuracy.
Absolutely. Yeah. It's perfect. Thank you. So one other way that you can optimize things is just by keeping it as lean as possible. If you're talking about one of those pipelines you saw on the previous page that's 20 tool calls long or something like that, there's a lot of inputs to outputs. A lot of the previous outputs are now inputs. This is an example, but imagine you do a Google search and you care about some basic answer, like, who owns CloudHealth or how does that work or something like that. You search the term, you get back the results. If you want to inject that information into an LLM, you could crawl all the pages on Google search and get all the text and dump it all into an LLM. And suddenly you're probably approaching 1 million tokens. Or you could just take the summaries and you can put the summaries in. Or you could do something smarter if this is actually your enterprise solution where you capture just the information that you know has the relevant things that you care about. And by doing that, like in this simple, trivial example, this reduces your cost by 100-fold. So, and this is just one prompt. You don't want to pay $5 every time somebody asks, what's CloudHealth? So definitely do your best to keep it lean, and not every response needs to be included in full.
Yeah.
So this gets into the first thing we talked about and the demo that Sanjna shared.
Do you mind if I?
Yeah, very bad. So there's choosing the right LLM. We saw that there's hundreds of solutions that you can pick from and different providers and all that. But there's also just making sure you're choosing the right solution for the job. Not every problem requires an LLM. You don't need a bulldozer to hammer in a nail. Some things, you should just right-size the solution for the task at hand. In this particular case, Sanjna's team made this incredible tool that doesn't utilize AI. It's just a sophisticated, rule-based approach that does a tremendously good job at identifying why something changed from 1 billion pieces of information rows or something like that. Imagine you have to put 1 billion rows into an LLM just so you can figure out something that her team was able to solve with a deterministic solution. So having a layer, or at least an understanding that your GenAI solution should have non-GenAI tooling. It doesn't have to be completely GenAI. So, yeah.
The smart summary here that he was mentioning, why something changes over time, that's rule-based. We have a sentence generator, which is ML-based. And then we have the intelligent assist questions, which can basically give you generic recommendations on how to optimize. The reason we decided to go with AI for this is because so many new cloud provider solutions come up every single day. We cannot possibly build a point solution for optimization for all of them. You just need to give this model a couple of months. Anytime someone puts a blog out there or the provider itself puts some information out there, this can just basically summarize it for you. We've noticed that a lot of engineers just need that direction. They just need to know whether caching works. For example, you're on here, you're learning about caching. It's a couple of sentences that we're telling you, but it's something that you can take home. And engineers usually run with this. So we thought that this is a great direction to go. But just this one feature itself as AI, as rule-based system, and ML-based. So we don't randomly want to just get everything with AI.
Exactly. And again, from a cost optimization standpoint and efficiency, you should have some idea of a flowchart like this. Something that helps you understand when should I be using generative AI. Not, assume that generative AI should be used for everything. And to be clear, I know people think generative AI is amazing, and it is. But for most specific tasks, regular machine learning models outperform generative AI models. Unless you're using it for something generative, like extractive summarization or something like that, there is usually a better ML model. Now, I would fully encourage that you use generative AI solutions to prototype. They can do almost everything, especially multimodal ones. You can build whole products with just one API, and it's incredible. But once you have that done, you're paying a lot. It's slow. You have a dependency on an external service, all sorts of things. So just make sure you understand the cost that comes from binding yourself to that, and then also be aware that you should, at some point, migrate certain things to either rule-based approaches, basic ML, or even just smaller LLMs like we talked about.
the most expensive part is hiring the right folks to maintain all the wonderful stuff in AI that you made. So we really have to be careful where we choose to deploy it.
The last thing I'll talk about briefly is governance and iteration, which is just, I guess, a fancy way of saying make sure you're paying attention. You want to build observability. This gets back to being atomic. Make sure the components that you're using are traceable, because Sanjna's use case and the CloudHealth use case is incredibly valuable. A lot of Gen AI is like, what's the weather outside, and you're sitting outside or something like that. You know what I mean? Like, it's not very useful. So in those cases, you want it as fast and error-free as possible. But in the FinOps use world, things are complicated and hard, and sometimes there isn't a right answer. So the value associated with that is really high if we can build something useful for them. And sometimes we might get it a bit wrong. It's probably going to cost more than what's the weather outside. But building tools that let us compare cost, latency, and user satisfaction, all these metrics with the task at hand, and then understanding the value of that task lets us put things in perspective, because it's not always obvious if you don't have those things set up from the get-go. So pair that with frequent meetings with the people that are actually using it, what they think, is it meeting their needs, are there gaps, are there holes? Like, as engineers, we miss the edge cases where people live sometimes. So you have to be careful. So meet frequently and build yourself those observability tools early on.
If I can just jump in there. I'm a focus contributor, and I've seen that be very common in the two buzzwords, right? Focus and AI. People just want to be involved and they want to have these in their organization, but then the starting question's not, I have this problem, that's why I know I want to use it. Just the fact that I want to use it, tell me how I can use it and make it useful for me. So I think both AI, and that's why our talk is called Beyond the Hype, right? These are so powerful. Like, I contribute towards focus. I know exactly how powerful it is, but it really should come from a problem statement. We always have to start from a problem statement and optimize forward.
Sure. Okay. Don't everybody screenshot this and let that with me.
This will blow your mind.
So, this is a basic breakdown of cost and latency optimization that we directly observed. This is not our exact cost, obviously, but the percentages here are roughly correct. So keep that in mind. Okay, so initial days, we did our foundation model analysis, like Sanjna said, and the model we ended up choosing had, the most important thing here is to understand 100 million tokens, not the monthly cost so much, but 100 million tokens cost us a little over $1,000, which is okay. The first major change that we made was the lift and shift to Google Cloud. Partly this was done for cost reasons, also at the time, and still Gemini is leading in terms of latency. But all that aside, that alone brought us down to $75 a month. So just be aware there is a big difference. It's not EC2 versus, GCP's compute instance, and everything pretty much costs the same. Like, we're talking like magnitudes of difference in cost for roughly the same degree of performance. So just do your homework and make sure you understand which models you want to use and how much they cost.
And this worked for us, right? Like, the Gemini model that we chose worked really well for us and gave us the same performance. But there might be use cases why you might choose the more.
Exactly, 100%. Our use cases were, like she said, very particular. And so I'm not saying you're the one should do Gemini. I'm not like a plug for Gemini here. But it did help a lot with our latency, and it did help a lot with our cost initially. But let's keep that now as our baseline, because things have changed. It was also 2 years ago. Things have improved. So the deterministic short circuit, I don't know if this was actually done third. Don't see it so much as in sequential order, but this means that we look for tasks that don't meet LLMs. We talked about Sanjna's use case, but there are ones all over the place. A step in your pipeline might be routing, and you were using an LLM, and now you're using an ML. Suddenly you're not paying for those tokens, you're not paying for those prompt tokens or completions or anything. So 15% of our workload was able to be migrated off of LLMs. So that's just an implicit savings. Token requirements. Prompt standardization needs to be a thing in your teams, because you start looking at the prompt that one engineer writes versus another, and they're wildly different. And to that end, if you try to adopt best practices with prompting and a consistent layout, you can reduce your waste. People throw a lot of words in there that they don't need to throw in. And if you know how to monitor your performance, you can bring it down a lot. So that brought us down another 25% or so. The biggest one here was that we were doing explicit caching off and on for a while, but in 2025, Google announced implicit caching with the 2.5 models. What this means is that they automatically detect if what you're sending, if the prefix matches with something you sent before. So all of those prompts that we have, we don't need to enable a flag or anything. It just comes for free. So you get 75% reduction on cost of prompts that they've seen before, which is amazing. So 95% of our tokens were able to be reduced by 75%. At this time, we also migrated from the older 2.0 models to 2.5, and we migrated some of our workloads from Flash to Flashlight. And again, this was that idea of making sure you're choosing the right LLM for the job. Because sometimes we were just picking the smallest model that worked because the task was so trivial. So then when Google or whatever your provider of choice is announces a smaller model, give it a try. See if it is good enough because it might reduce your spend in that particular way by another 10 or 20%. So at this point, one big thing to mention if I haven't hit it, cache hits don't just reduce your costs, they reduce your latency. So whatever your regular latency is, normally if you hit the cache, you're going to get a much faster return. In fact, most people don't realize this, but the longer your prompt part is, the slower your overall return end-to-end will be. So even if all you want is one word, if you send in a 50,000 word prompt to get one word out, that's slow. It will be slow. Much slower than if you send in a 2-word prompt to get a 1 word back. So caching is sort of like, you get to say that however big your prompt is, it's like 2 tokens long, and suddenly you're at like the max performance you can be. So it's a very positive thing. So that's where we're at now. We're down almost 99.6% from our original cost to now, which when it's $1,000 doesn't matter that much, but suddenly you're getting the workloads, tens of thousands of users, and you can imagine how big a deal that actually is. So make sure you're doing your best to apply some of these principles and be pragmatic. I think you can make a big difference.
I know to a room full of FinOps practitioners, this sounds like a dream, right? Like reducing 99.6% of your cost, that sounds like a dream. An example, if I may, of prompt compression would be, can you please build me my monthly EC2 cost? Thank you. That's a prompt. It'd be nice, that's awesome, but build me my monthly EC2 cost is all you need, right? Or monthly EC2 cost, that's all you need, and it will do it. So that you've already cut your words by half. Awesome. So, testing intelligent assist. Did you touch on always having to choose LLMs, or where you can choose small or medium language models?
More that previously we were mostly just using the biggest one we could, and then at mostly earlier this year and at the end of last year, that's when we started introducing smaller models for more of the tasks. And now we have 3 tiers of models, and then the deterministic models.
Right, exactly. So we've all heard of LLMs, super popular, right? Buzzwordy. But there's also small and medium language models. All language models don't have to be large. So for a lot of use cases, a good way to optimize is to ensure that you do indeed need a large language model. Small language models can even run on your laptop. They can be as small as that. They don't have to be as expensive and complicated to maintain as large language models. We did choose a large language model, and we've chosen Gemini. Now, how do we test it? How do we know that this tool works for a FinOps use case? Okay, so the metrics that we measured is query accuracy. So we saw a demo of how you could ask a question and what the answer looked like, but I have another example here. And what's happening under the hood is this SQL query that you can see. So what we've done here is taken your English sentence. We pass absolutely no sensitive information of the user whatsoever. We have data sets. We heavily write column descriptions for these data sets. So when the user says build cost, the model understands what column to look at out of the 50 options it has. Or we try our best to make sure that the model knows. Once the metadata of the data sets are exposed to the LLM, it writes a SQL query. That is the only LLM component that we have used in this use case. The user asks the question. We try to translate that from English to SQL based on the metadata that we have exposed to the LLM. This query accuracy is very important to us. We then further ask the LLM what is the best way to represent this data, and then we render a chart. So absolutely none of the data of any customer-sensitive data goes anywhere outside of our system. This query is super important. We check if the data in the response is correct. Is it the right cost, dates, categories, have we gotten all of that right? Intent recognition. So did the user try to summarize the question? Did they ask us to find optimization recommendations? But did we still kind of force a report generation? That's not what the user wants, right? The user wants a report. They don't always use the word report, but we are supposed to identify the intent of the question. And any ambiguity. So when the user said compute spend, what exactly did they mean by spend? And what is the boundary of compute? Is it Lambda? Is it only EC2? Is it AWS? Is it Azure? Is it multi-cloud? Kind of understanding what the intent is. Query quality. Is the SQL able to run? Right? Did we choose from the right data set? Did it run successfully? Did it run a good query that was without errors? Hallucination rate. So we earlier talked about smart summary and how we generate textual responses. It does hallucinate. Like we've seen, I wasn't able to, unfortunately, fortunately, I wasn't able to get an example that we stopped our model from hallucinating. But a year ago, our model recommended RIs for non-reservable instances. We would just recommend by an RI. So we've seen hallucination before. But we monitor for things like this. This is how we know that our system is working. What methods do we use? So we have a validation data set of questions that we think are crucial for our user to find something that they can share with their users. This validation data set is popularly asked questions. It is our benchmark for testing. Human in the loop. So you always need a human expert in the loop to know that the answers that are being given are valid. We check our responses against all the metrics that we mentioned. Any textual answers are read by a human, validated, and checked.
And if I could just throw one thing in.
Yep.
When we talk about working backwards from value and we talk about testing and we see that we need people in the loop and this validation data set thing, something as engineers we come across, and probably everybody here comes across to some extent, is when somebody wants something but they don't know how it works or how they're going to get it. They're like, give me this thing, and then you have to figure out how it all works. But that's the important bit. You have to actually figure out how it works. You have to connect with somebody. Like I have to talk to Sanjna, and she has to help me understand how FinOps works, what those commonly asked questions are, what really brings value. And so you need it on both sides. You need it on when you're developing prompts and everything. And you also need it on the validation side when you're reviewing what comes out. Because it's easy just to assume the AI will figure it out. And it won't. Like you need that human in the loop. It's very important.
And most importantly, FinOps practitioners, like FinOps experts in the loop, right?
Yes, exactly.
People who know their stuff. I think that was it from us.
Yeah.
We will take questions now, but we also have an Ask Me Anything with Darien. I will be in the background if you want to ask me questions, but he's the one you want to talk to. He will be around for the next hour. I also missed mentioning that not only are there 250 Grandmasters in the world, he ranks like 10. So he's one of the best that's out there. So if you have any AI questions, call up your engineers right now and ask them all their questions. You can bring it to us.
Yeah, thank you.
Thank you.
That was a long time, so. But yeah, if you have any questions, it doesn't have to be necessarily about what we just talked about. It can be about anything. I'm just whatever you want to know.
Yeah. And if you like what you saw and you want a demo of the CloudHealth new experience, you know where to find us in our booth, or we're here to talk to you.